simplifying using reciprocal and quotient identities. So in our previous video, we talked about 3 different types of identities: reciprocal identities, quotient identities, and Pythagorean identities. This video will just talk about simplifying using reciprocal and quotient identities. These are ones that we've used for a while, and the reciprocal identities are the 1 over, so the flipsy flu, and the quotient identities are just tangent and cotangent, and they're made up of sine and cosine. All right, so simplify using only algebra and the reciprocal and quotient identities. So the big tactic here, there's many ways to simplify these. There are clever ways to do it so that you're doing the least amount of work. However, the most surefire way of getting to an answer is by rewriting everything in terms of sine and cosine. In terms of sine and cosine only. So we have tangent x, cosecant x. I would want to start here taking tangent x, and I'm going to write that as sine x divided by cosine x. Then for cosecant x, we're multiplying by, this will be 1 over sine x. I see a sine x on top, a sine x on bottom. This simplifies to 1 over cosine x. And I know by the reciprocal identity, where are you? That 1 over cosine x there, that is secant x. And that is as simplified as I can make it. That's my final answer. So not so bad. Not so bad, right? The hard part can be when it's a little bit messy on the fractions, but it's not a big deal, and we'll look at some of those right now. All right. We have cotan x over cosine x times cosecant x. So cotan x, cosine x, cosecant x. Cotan x is by the quotient identities, cosine x divided by sine x. And then the big fraction bar, cosine x was just gonna stay who he is. Cosecant x is 1 over sine x. From here, there's a few things that could happen. You might get to your answer immediately by being a little bit observant here. On top, I see a cosine over sine. On bottom, in your head, you can see what would happen, right? These two things would multiply, and you would get the fraction cosine over sine in the denominator. So you know that you're going to have cosine over sine divided by cosine over sine. Same thing in the numerator and denominator. This should cancel to 1. But if you wanted to do a tiny bit of algebra here, you could multiply the numerator and the denominator of the big fraction, the really big fraction here, by sine x. That would cancel the denominator there. It would cancel this denominator. This would give you cosine x divided by cosine x, which is very obviously 1. Boom. One last one. So normally when I see simplification and I see something like cosecant squared, my brain immediately is going to say, use a Pythagorean identity because I see a squared. However, this problem says reciprocal and quotient identities only. So I'm going to just replace it with a reciprocal identity. So I have cosecant here, we have cotangent, we have tangent. Cosecant squared, that's 1 over sine squared. Divided by cotan squared is cosine x divided by sine x times tangent, which is sine over cosine. And hey, something interesting happens here, right? those cosines cancel, these signs cancel, the whole denominator turns to 1. That's really interesting that cotan x, tangent x, the soulmates of each other when multiplied, are equal to 1. How interesting that is. And it makes sense, right? We know cotan x is 1 over tangent x. So 1 over tangent x times tangent x, of course that equals 1. Any of the soulmates multiplied together, this will be true. Cosine x times secant x. Those will multiply to 1. Sine x and cosecant x. Those will multiply to 1. They're part of their soulmate ship. And maybe I'll highlight that because it is quite an interesting fact, I would say. All right, so we get down to the numerator is the only thing left over, 1 over sine squared. And we would want to convert this back into cosecant squared. So if we'd had a lot of good foresight here, we might have been able to see that we didn't need to change cosecant. Maybe we had seen, hey, I have a soulmate multiplied by its soulmate, that'll turn to 1. It's just going to cancel and be what the numerator is. So that's, if we had seen that, we could have saved ourselves the step of converting and then converting again. Anyway, so that's simplifying just using those basic quotient and reciprocal identities. In the next video, we'll talk about adding in Pythagorean identities to it. I'll see you in that video. Bye.